This spreadsheet draws different probability distributions and solves for areas under a curve or the value for the random variable given an area in Excel. And I do this for the binomial distribution. I do this for the normal distribution, where when you change parameters like the standard deviation or change the mean, you can see the shape change. I have one that's the normal distribution for any values. I have one if you're solving for a random variable given an area under the curve in the tail. I have something that is about the standard normal, and then just a very simple demo that showing the different shapes of the t-distribution versus the standard normal when the sample size changes. So when the sample size is very small, you can see that the t-distribution is flatter and has more area under the tails, but as the sample size gets bigger, you can see it gets, and when you get to 30, it's almost identical, and anything over that, they're the same thing. For the binomial distribution, if you provide the inputs of the number of trials, the probability of success for any trial, and then a specific random variable value, it gives you the Excel formula that you need to solve for, and it solves for that. For example, given a binomial distribution with number of trials of 6 and the likelihood of success for trial is 50%, what's the probability of getting exactly 5? Exactly 5, it'll generate the formula for you there. The probability of getting less than or equal to 5, it gives you that, and here's the formula. And then if you want to solve for the complement of that. But you can change these, so if the likelihood of success of a single trial is 20%, you can see it changes, the shape changes, it tells you what you're solving for, it also generates the probability distribution table. It'll calculate the mean and the standard deviation for you. Again, over to this one, the area under the curve is represented in this blue. If I change the mean to, and right now for this one it's more of a demo, it's between -10 and 15. So if I make the mean 5 and the standard deviation of 2, and I want to solve for the likelihood that I would generate a number that's less than or equal to 4, this is the shaded area. Here's the formula that you would use in Excel, and that formula is dynamic. So if I change this, it says, well, what's the probability of less than or equal to 3? Or I can turn this around and solve for greater than that. This one is exactly the same thing, except you don't really see the shapes. The axis is dynamic, so it will change. It will always look like the standard normal problem. In this one, the standard normal doesn't change, so you can get a feel of how you solve a standard normal problem, which is the same as solving a regular normal problem. And it always gives you the Excel formulas. This one, it gives you if you're solving for specific value on the x-axis given an area. So if we have a normal distribution centered at 15 with the standard deviation of 1, and you've got in the upper tail 5%, what would that value be that would represent that? It would be about 16.6. If I wanted to say, well, what if that was 10%? Make that a little bit more, it would be 16.2. I can always solve for the less than, but usually you use this to solve the areas in the tail. Oh, excuse me, there's your less than 0.1. And so it's solving for areas in the tail. The standard normal just gives you an idea that if you wanted to find the area in the between two values, so plus or minus 2, standard deviations from the mean, you can see that area is 95%. And I can make it -3 to 3. I can make it -1. I can do whatever I want, and I can solve for that area. So this spreadsheet has been very useful for me when I'm teaching probability, the normal distribution, the binomial distribution, and it's very useful in an online class when it's hard to draw the probability distributions by hand and turn those in. This spreadsheet allows you to draw them in a spreadsheet. Thanks.